Hello everyone and be welcome to the channel Kubax3. And in today's video, we're gonna talk about movement through a trajectory. And for that, we're gonna use animation curves. And you may ask, what is animation curve? Well, basically animation curve is a mathematical function that maps a curve using a time that goes horizontally with a value that goes vertically. With the time, we maps where the time is and we get a value that I shown to you right now. And with that, we use the image curve for the name suggests animations, but we can use for other things. In my case, in this case of this video, movement. But beyond these two, it could be used for numerous things that I can list in this video. Here in the Unity, I have this projectile here. As you can see, it's make a trajectory independent of the position that it is, and it makes a trajectory. This is the trajectory that this projectile is making, and independent of the rotation of the projectile it moves, it makes exactly the same path. As you can see here, it's towards 45 degrees to the right, and it makes the exactly same path. And if I rotate it to the left, it's making other exactly same path, independent of it is. And also this is the projectile invoker. This is what makes the projectile in spawn in the scene. This is the projectile itself. This here from this the below here for these to down. These are the most important. These are all the statistics that makes the projectile makes this path that you're seeing right here. And is that all these configurations in the code of the projectile that I'm gonna show to you right now. So we are here in the code of the projectile as you can see. And this the first thing is that we can see is the variables that we're gonna use, all the variables that we're gonna use. Some of them are not needed because they are not important for the code. They are just some add-ons so that we're gonna use for the things like the render of the sprite and some screen shaker for impulse or other things. They're not needed. They're not so important for the code. The most important things is is down here. First of all, we have the initialize method. Here we have, first of all, we get our initialized status. This status right here, at this structure right here, that contains the position, the rotation, and the layer that the projectile needs to be. And we're gonna set the layer of our projectile of this layer that passed through here, and the position and rotation. We have right here the most important thing right before this, right after I got a mistake, right after this, that are the position of our projectile. We have right here the begin position, the next position, and the destiny position. The begin position is where the projectile starts in the trajectory. So it's the beginning of a projectile in the trajectory. Always gonna be in the always gonna be the beginning of the projectile in the current animation curve because I don't show it to but it's more than one. It's a list of trajectories that we can have. So the begin position gonna get the current start position on the current animation curve. The next position is the next position that our projectile needs to be, and the destiny position is the final destiny, is the final point on our animation curve. So the beginning position is the first point, and the destiny, the last point, and the next position that the projectile needs to be. Here we have the trajectory distance. This here is the distance that we travel in the trajectory. So this gonna receive our time. Remember that we get the value on our animation curve based on the time. So this variable right here, we're gonna receive the time of our animation curve. And based off or this variable here, we get our value. The current curve, that is the curve that we using in the moment of the or list of the trajectories. This last point here, we're gonna receive the last point of our position of our time. This last point here, we're gonna receive the last point of our time of the current curve and the value of the current curve. So the x is the time of the current curve and the value is the y of the current curve. Here we attribute the destiny because here we grab the begin position where the projectile is, and here we attribute the destiny based on the forward direction and the side direction. The forward direction we gonna attribute it based on the time of the animation curve. So we're gonna grab the last point here. We're gonna get the point, the time of animation curve, attribute if the forward direction that is the up direction of our projectile, and the side direction is the right direction of the projectile curve, and we're gonna attribute it using the value of animation curve. I will attribute the direction, the forward and side direction, and attribute it to the destiny our of our animation curve of the projectile. So right after we attribute the destiny of our projectile, we're gonna go here down for the movement. So this is all the code that the projectile makes to move. Right below here, we grab our current position. Oh, no. We grab the next position and attribute it moves the projectile towards the next position. This is the code. And here we attribute the next position. Here we just grab the movement if you want to move a fixed speed towards the entire trajectory, or we want animation curve to make the speed of the trajectory. This is not so important. You make it if you want. This is not important. But here we make our first verification, that is the if our current position is equal to our next position. So if the current position is equal to the next position, is the distance is 0, we're gonna go here and attribute the next position. First of all, we verify if the next position or the current position independent of you put here, wherever you will put here, but you have to verify if the current position is equal to the destiny. So we're gonna make this right here. If it's not equal, otherwise, if the current position is not in the destiny, we're gonna grab the time of our animation curve, that is the distance that we are traveling, and we're gonna increment it using the speed that we move plus the simulation of the physics. And we're gonna grab it and verify if the speed is more or equal than the last point of our animation curve. Is the last point or is the last point that the x last point of our animation curve, that's the last time of our animation curve. If it's more or equal, we just gonna attribute it. If it's not, we attribute more. And here down, right here, is the attribution of the next position. First of all, we grab the begin position. Remember, the begin position is the position that the projectile starts the trajectory. So it's the first point that of the trajectory. plus the 4 direction multiplied by the distance. So we grab the direction that our projectile is and multiply it by the distance that we're traveling, that we traveled here, plus the side direction that is based on the value of animation curve, multiplied by the value of animation curve, evaluated by our distance, that is our time of the animation curve. And the last thing here, we just rotate, or the projectile, we just rotate the projectile based on the direction that our projectile here. So you grab the next position, the current position, and rotates our projectile towards this direction, the direction of the next position. With the attribution of the next position made here, we move our projectile towards the next position right here. We verify if the current position is equal to the next, and here we verify if the current position or the next, whatever one here, is equal to the destiny. So if is equal to the next position, we're gonna make this right here. We're gonna reset our distance. We're gonna reset our distance for the zero for the next point based on the zero of the next trajectory, and we're gonna attribute the beginning position with the last point of our animation curve. You can attribute the destiny right away here, but I separated because with that here, I make you make with this here, you make a interesting behavior on the projectile. Here, as you can see, I mandatorily I attribute the time. Remember, this is the time on our begin position. Make the begin make making the last time, the last point of the last time of our trajectory begin equals to the begin position. So the begin position now is equal to the next time of our trajectory, of the current trajectory that we use in the moment. Here we choose to attribute or not, we choose to increment the sideways of, of the projectile or not. Here is the value, so we choose to attribute the value or not. I'm gonna show you after this, after I show you all the code, how this works in the practice. Right after we attribute the destiny to the begin position, now we're gonna grab the next curve, the next trajectory of that we need to move our projectile. We're gonna increment the trajectory index if the index is less than the length of the list of our trajectories, or if you want to repeat it, we're gonna repeat the trajectory. So if the index is equal to the length of the trajectory of the list of trajectories, it's gonna repeat to the zero. And here we attribute the index, and here we get the curve based on the index of our list of the trajectories. After that, we're gonna get the last point based again in the last time is the x of a last point, and the value is the y of a last point. So we're gonna grab the last point of the curve of the trajectory. And here is optional, as you can see here, is optional if we want to rotate the projectile and we increment the rotation of the projectile. This is a little hard to explain right here, but in the Unity, in the error of the Unity, I'm gonna show you, you're gonna understand how this works. But as you can see here, I just grab the four direction and attribute it with the up of our projectile again, And the side direction, the same thing. I grab the right of a projectile, attribute it on the side direction. Make it if our projectile ends up in a direction, in the up direction and forward direction, different from the forward and side direction, the side direction and the forward direction here gonna be different from where it starts, right? In the right in the initialize method we're here. So we reattribute the forward direction and the side direction down here. And after that, we're gonna do the same thing that we did in the initialize method and grab the destiny based again in the begin position that remember we reattribute it with the destiny of the last curve, the curve that we moved before. We attribute the curve to the next curve, and with the current curve now, the begin position is the last point of the last curve. With the last point of the last curve, we're gonna attribute the new destiny based on the new curved curve, the new destiny of the new curved curve. Therefore, direction here, if we attribute here, it's gonna be different from where it starts. Again, we're gonna use the last point, it's the time of the curved curve, and the x point, the x last point of the animation curve, and here the y last point of the animation curve multiplied by the side. This is the same thing that we did here in the initialize method. We attribute the destiny here with the begin position. We attribute it the forward direction and side direction that it's optional here. We change it here if we want. And attribute the last point, x last point with the forward direction, the y last point with the side direction in the destiny. Is basically the same thing up here. The begin plus the forward direction multiplied by the x of the last point plus the side direction multiplied by the y of the last point. Here the destiny gonna be different, and after that we're gonna repeat, so it's gonna repeat again. So we're gonna repeat here the next position is begin is equal to the begin position that is different, we attributed here, plus the forward direction that can be changed if we change it, plus the trajectory distance that we resetted here, plus the side direction multiplied by the evaluated value of the emission curve. And right after that, we attribute it to the next position. So it's a loop, makes an entire loop towards trajectory towards trajectory to trajectory, and makes it. So this is all the curve, all the code that we use and we need. This is all. I gonna I gonna make I gonna compact here for you to show all the code. So this is the code. You can screenshot to rewind the video to see more. So now I'm gonna go to Unity Editor and show how this works. I made some projectiles to show you how of this all of these configurations works with each projectile, and gonna see how this all works. So for now, go to editor. So right here in the Unity editor, I'm gonna show you this first projectile here that contains four animation curve, four trajectories, and you're gonna repeat the trajectories. So when the index of the trajectory goes to the last, it's gonna repeat after the last one. So as you can see, it will make the first trajectory, make the second, the third, the fourth, and after the fourth, it will go back to the first and repeats again infinitely, endlessly. As you can see, and this is This is the basic configuration. This uses the basic configurations. The others configurations gonna be way more interesting to show to you, but that's the first. That's the base of the code. The second projectile that we're gonna use is this projectile right here. And with this projectile, we're gonna rotate the projectile towards the trajectory. So the projectile will follow the path of the trajectory. And at the end of the path, we're gonna increment the rotation of the projectile towards the trajectory, towards where the trajectory ends. And this is the path that you are seeing, and this is the projectile, what he makes. As you can see, when the projectiles at the end of the trajectory, the projectile repeats itself, or he increments the rotation where it ended, and it repeats again the trajectory with the rotation incremented. As you can see, it ends with a different direction and it continues with this direction. This is the this is both this this is this settings. If I turn off the incrementation, as you can see, as you are seeing that, as you can see, the rotation is not incremented and it's resetted from when the projectile starts, from where this starts. I'm gonna go here to and gonna make the projectile face 45 degrees to the right, and it gonna, as you can see, do the same thing that I show you. And I'm gonna turn on this again, and as you can see, it makes the increments the rotation again, but with the initial 45 degrees that it started, as you can see. This is this is what these two rotations here do. The first rotates the body of the projectile towards the path, and the second increments the rotation in the directions, in the forward and side direction of the projectile. Third and last projectile here is not only one but two. One that go to the left and other to the right that are seen right now. And when I shoot, we have two at once. And these two, I use it to show to you the increment sideways. This here. Remember that we only mandatorily only applies the time on our begin position or destiny to our begin position only our time. Well, the increment sideways we use the value too. So when the projectile ends in a different way or where it started, we can increment the sideways, the value, so the projectile will make like this. I can, and we could make other. This is the what the increment sideways do. What we do. This projectile here is not so good to see. I'm gonna change it a little bit, and I show you more to you to see more clearly the projectile. So I changed the projectile a little bit to see more clearly what he do, and as you can see, he you can see more clearly what he do is the exact same path, but is way more not so zigzag than before. And as you can see, the projectile goes left because he ends in the final. The end position is different from the start because we're using the sideways. If I dismark this setting right here, as you can see, the projectile no longer goes to go, so I forgot to mark the right option too. But as you can see, the projectile makes a snap to the begin position because there's no connection. So you can see also that he breaks. It's go weirder every time because it's not going it's not going out. It breaks the path that's the projectile makes. So I mark the sideways in the tool, and the tool makes what supposed to do. So this is what the increment sideways do, and this is why I separated the two. You can make the two equal, make the destiny apply completely in the begin position. You can do that, but I prefer to make this to make the things more clear. But there is no problem if you do in the array. So basically, this is all for this video that I showed to you. I could I didn't explain some things like the initialize method and the other properties, but I didn't explain because the initialize method is part of a pull system that a custom pull system that I have made. So I didn't explain it because I will have to explain the entire system to you. But this video is only the purpose to explain the movement of the projectile using animation curve, and also I gonna make other video using the post system that I created. So I didn't explain it because of that. And this is all the video that I created. So basically it. I hope you like. Come please subscribe in the channel too. Comment for feedback. And this is all. And goodbye for now.